All right, so hopefully all of you have a graphing calculator in front of you. I'm going to use this graphing calculator right here on the screen. Just as a reminder, I think I've sent a link, put a link up in Google Classroom for you to download this onto your computer if you want. It's a free download. You should all try and do that so you have access to graphing technology at home, whether it's this or another program, but this is the one that you'll be able to use for tests, right? So good to practice this one. So what we're going to do is we're going to model a sine graph with some data that's given. So we're going to first have to plug in the data into the calculator. So here's as I mentioned before, here's the steps, or here's some notes on how to do that. And so in the stat menu, that's right here, you want to press that button on your calculator and use the right, and then just hit enter there, I guess, for the list. So let me get this calculator up here. So turn it on, clear that away. Might clear these away too. So stat, enter. Now if you have numbers in your lists, I would encourage you to go up to highlight the name of the list and just hit clear and enter, and it will clear that list. Please don't delete, but clear. And then for number 3, as we mentioned here, we have to, where'd it go? We have to put in some data here. So obviously we have two quantities, the day and the angle of, looks like, I didn't read the question yet. So while on her nightly walks with her dog, Kelly noticed that the moon appeared to be at different angles on different days. She researched the maximum altitude of the moon in degrees and obtained this data starting on April 1st. So she's walking and she sees the moon here, and then she sees the moon up there, and so on. So different angles from her position. So she researched these angles. We have two quantities, days and angle, looks like of elevation, of the moon. So graph Kelly's data and estimate the period. Okay, so let's graph the data first, and then we'll look at the period next. So on your calculator, I want each of you to do this. Please no writing fancy messages to each other. Please do the question. All right. I'm seeing some disturbing messages on the calculators. I want you to avoid that, please. Laughs over here. Okay. So go ahead and take a moment to input that, and again into your calculator here. Probably the day would be list 1, the angle would be list 2. So take a moment to do that. All right, so once you have your data into your calculator, okay, you had a chance to do that if you're just finishing up, then we need to graph the data. So who remembers how to do that? What's the next step here in graphing the data? Go ahead and shout it out. Yeah. Stat plot. Okay. So second function y equals. What does that give us? That gives us the stat plots. Awesome. So let's enter to get into 1. Let's turn 1 on. Now let's just double check all this stuff here, which we want a just points to be plotted. So this one's always highlighted for us. And then X list. Okay. So it looks like I have to go down and change my X list to list 1 and the Y list to list 2. Okay. All right. Now the other thing is the window. Once you've got that screen set, you want to make sure your window is appropriate. So the days go from 1 to 59. So that's on the X. So we should go from maybe, let's do -2 just so we can see the axis there. So a little bit below the minimum, a little bit above the maximum. Let's go 62 maybe, so we can see all those points. And then down to Y, what's the smallest Y value that you see here? There's a 16.9 there. Did you see a 16 point something else? Okay, 0.7. All right, so let's just go well under that. So let's just go 12 maybe, so we can see this on the screen real well. And then the largest one looks to be what, 63 and something. So let's go to here, let's go to 66 maybe. That's what I'm going to do. All right, so hopefully the windows are set now. We hit graph. Oh wow, look at that. So here's the plots, and yeah, it does look very sinusoidal, doesn't it? It looks very repetitive. Okay, so just give me a show of hands who has this on your screen right now. Okay. Okay, so if yours has other lines in there, that you want to hit Y equals, and you're going to erase, you need to delete whatever's programmed there, because it looks like you probably have something programmed from other classes that have used this. All right, so estimate the period. So let's go back to that graph. How can we estimate the period? Well, you could hit trace. You could hit trace, and you could kind of say, all right, well, there's kind of my beginning point. And right now, this is just going to pop from point to point. This appears to be a maximum, and it's at x equals 7. So if we go over to the next maximum point, right here, that's x equals 35. So one complete period would be about maybe 28. All right, so that would be the distance or the difference in the x values between corresponding points on two successive sort of cycles, right? So a maximum to a maximum. So you would maybe guess here, and you're going to write this down. This is part of your assignment, so I'm helping you out here. So graph Kelly's data. Now what you need to do is you need to sketch this. Again, just sketch it really quickly so you can show in your book. Even though we're graphing on the calculator, you need to transfer that just real quickly into your notebook. So as you do that, you're also going to write down the period, which we said was 35 minus 7, or 28. Okay, so take a moment to do that. That's A. Okay, so that's what your A might look like here. There's a bit of sketch of the graph. The period's approximately 28 days, and how'd you get that? Well, we went from sort of top of the crest here to the next crest. The difference is 28. Okay? All right. So B says, explain why a sinusoidal function can be used to model the data. Okay. I mean, you could say this looks like a sine graph. You should probably be a little bit more detailed than that. You could say that there is a repeated sort of increase and then a decrease. So you could say for B, it looks like a sine graph. It looks like y equals sine x shape, you could say. The points do. You can say it increases.
A ROG4, and it's the color of gray with a license plate 638.
Increases and decreases periodically. Those are some words that we used to describe the sine cosine graph, periodic function. Okay, so anything like that you would put for B. Okay. All right, you could go further than that, but that's all we'll do for now. So C, determine the equation of the sinusoidal regression function that models the data. So here's the big deal, and again, you've done regression functions before. Actually, let's go back to to the notes here, and we'll maybe skip back up to the instructions there. So we want to get to the calculate menu, and then we want to find sine reg down here, right? So we want to go stat over to calculate, and then we want to go all the way down to the bottom of the list there, I believe. Yeah, you can go up from the top, you can go up to get to the bottom there. So sine reg. Whoops, I should have cleared that, so let's do that again. So stat, calculate, sine reg. And what do I do after this? You remember?
Second function one.
Yeah, you got to tell it which lists to take the data from. So we're going to do second function 1, so that's list 1. We're going to do comma second function 2 for list 2, if that's what you did. Whatever the lists, so you put your x and y in, do that there. And then I showed you one other shortcut, right, with this calculator that we could also do that will actually get the calculator to put the equation into the graph and graph it, so you don't have to recopy it in there. And what was that? Do you remember how we get there? Vars over to y vars, and then enter, and we can put it in the first y value. Very good. So that's vars over enter, enter, and now you enter again. And does it take a few seconds here? Okay, so it's taking in the data, it's squishing it into a function, it's thinking about it, plotting it, and there we go. Okay. So your job now is to write down the function that models this from the calculator. So this is not good enough just to copy this screen, okay? Just letting you know that that's not good enough. You have to put it into the sine form, okay? So what I mean by that is this. So for this would be C, I guess. Okay, we're going to plunk that down there. So what you need to do then is you need to go y equals, what's the a value? 22.96. You just go to a couple decimal places is fine. Sine. Okay. The b is 0.23 x. Now this c value here, they don't have a separate set of brackets, so you can write it just like they write it there. So it says plus c, but the c is negative, right? So we'll go minus 0.209. And then we'll go plus the d value, which is 40.287. So from your calculator, you just copy that screen out. And so back on the calculator, if we look at the y equals now, it should have put everything in there, right? So there's your a value, all of the decimal places, which is really nice. But 0.23x minus 0.209, so on and so on. So now if we graph, we should have all the points and the sine graph that the calculator has generated for us. And so it should look something like this. You want a graphing calculator there? Got one?
You got a graphing calculator?
Okay. So any questions on that? There's your answer for C. Okay, determine the equation of the sinusoidal regression. So that's what we wrote down. D, what is the maximum angle of the moon? So the maximum angle would be a maximum y point, right? So what you could do is you could look at the points that that we've plotted, or what you could do is look at the regression function. So if we're talking about the maximum, what you're going to want to do is you're going to look at the function and try and find out what the maximum point of the function is. Okay? Not the largest point here, because these points maybe don't represent the highest point, because they only took these measurements every other day. So the maximum point could have been reached in between those measurement times, right? So that's why the regression function is really good, because we can calculate very accurately what the actual maximum is. We don't have to look at this and say, oh, it looks like 61.7 or 63.1 or whatever, that's our highest point. Well, you know, it may have reached the highest point between 7 and 9 days there, right? We don't really know. So how do we do that? Have I told you how to do maximum values here? Okay. So on the calculate menu, so that's second function trace, the calculate, we're going to go to maximum. You see that? Maximum. Number 4, maximum. All right. Now, because this is a sine graph, it doesn't matter which peak we're going to look at. So this is what the screen would look like. And it says left bound question mark. So for those of you that haven't done maximum before, this is what you'll do. The cursor is somewhere here on your sine graph. You see that? It mentions it up top. And so left bound, what it's looking for is the left boundary to what would be the maximum point. So you want to have your cursor somewhere to the left of the maximum point, and in this case, that's a good spot. So I'll just hit enter. Now the calculator is going to say, okay, I'm going to generate, or I'm going to look for a maximum point on the right side of this minimum. Then it's going to say, what's the right boundary? So here you just keep tapping the cursor until the cursor is somewhere to the right of what your maximum point is estimated to be. And so you see how you have these two little arrows now. And that means the calculator is going to look for the maximum point in between those two boundaries. And then when the calculator says guess, that means it's ready to calculate your maximum point. So you hit enter. It may think for a moment. And look at this. So at x equals 35, so 35 on our list is right here, we have a maximum point of, and that's actually just beyond 35. All right, but we would have a maximum point, where are we? So a maximum point of 63.24 over there. Interesting. Okay, so let's look at that again. What's the maximum angle of the moon? If you do this and you do have a point on your list that is greater, I guess the flip side is true, that there may be a maximum point inside those points, but because this is a regression function, let me explain why we might see something like this. Okay, so it's a good thing this did come up. So here we go. We have points like this, right? Something like this. And the regression function may look something like this. It's a calculated function. It's very, you see, but it goes through most points, but not necessarily all the points. So what we've done is actually we've calculated the maximum point of our graph, right? Which, according to the graph, the maximum value is 63.2. Now, what you can do is you can now say, well, because this is a regression function, it looks like it's not going through one of the points that maybe would yield the maximum. So if that's the case, and again, I know this is a lot of thinking, but you would want to say, you know what, 63.2, there's actually values that are above 63.2, and there's one right here. Is that right? So if you see a value that's above a calculated value, then you can write this one down. What's the maximum angle? This would be the maximum angle that we can determine via the regression function or the table. Okay, so you would be okay to do that. So D, maximum angle is 60, what was it, 63? 63.5 degrees. Okay? Any questions? All right. All right, so estimate the altitude of the moon in degrees on day 100. Okay, so here's where we definitely will need our regression function because we're estimating. And so what you do here is we're only going, the window only takes us up to 62. So what do I have to do? What do I have to do here? I need to see where 100 would be. So I need to go down to my X max, that's the days. I need to put it just over 100 there and see where the graph would be. So this is estimating sort of into the future. Okay. Now day 100, day is the X value. So it's actually pretty easy to find this. You go second function, trace, and you just hit enter. Enter in an X value, and we put 100. And so this says 23.2 would be the degrees, the angle of altitude of the moon. So 23.24 you could put, that would be an exact answer for that one. 23.24 degrees on day 100. Okay, is this making sense here so far? And then finally, the last question, what is the first day in May that the altitude of the moon will drop below 30 degrees? Okay, so starting April 1st, this data is starting April 1st, so what is the first day in May? So how many days in April?
30.
Okay, so we have to go beyond 30, so we have to look from 31 on, right, or beyond 30 anyways. What's the first day in May that the altitude of the moon will drop below 30 degrees? So after day 30, we need to find out where the first point that it drops below 30. So what we can do with our graphing calculator there is we can do this. 30 degrees is a y value. So if you go down to another y equals, and you type in 30, just 30, that will generate a horizontal line, and that's kind of the cutoff. So at these times where it intersects the graph, that's where it hits 30. All right. And so what we'd have to do is we'd have to find out, on what day does it drop below 30, and that's after 30. So let's just kind of hit the trace button. So that's day 17. Okay, where's day 31? Okay, there's day 31 right there. So it's going to be, I don't know if you can see this very well from where you're sitting, but it's going to be this day right here where 30 intersects with the graph. So if we skip through along those points, here's day 43, and there's day 45. So it's going to be somewhere between 43 and 45, maybe on day 43, maybe on day 44. How can we tell for sure? Well, what we could do is we could find the intersection point. And so here's another function that you can use your calculator for. Intersection. So again, second function trace gets you the calculate menu. Okay? So you want to calculate the intersection. Who remembers what we do after I hit second function trace and then hit that number 5 for finding the intersection? Remember what we do here? Heads up, please. Thank you. What's the calculator asking me for? First curve here. Yeah, it's asking for the first curve. So here's the sine graph. You hit yes. The second curve. So when they say curve, they mean line, graph, function, whatever. Is it 30? Yes. Now, when it says guess, what you have to do is you have to put your cursor at or very close to the intersection point that it's trying to guess. And so you hit enter, and it should calculate this intersection point. So that's day 43.8. So what would be day 43.8 after April 1st? Sorry? May 14th? Okay. So April 1st, and then add 43.8. So May 14th, you're saying? Okay, take your word for it. It sounds about right. So F, you would say May 14th would be the first day that it drops below 30. Okay. And so again, I know that the answers, the solutions are in your textbook. Please make sure you go through this process so you know how to do this on the test. Okay. Don't just say, you know what, I'm just going to copy down the answers from the back because I'm pretty sure I know how to do this. So make sure that you go through the process yourself. And anyways, that's a little bit of a hint, number 3, on how to do all those things. Okay? Does anybody have any questions? Okay, you have the rest of the class to complete the assignment right here.
Mr. MathWell?
Mm-hmm. And here's number 8, question about our fair city. Look at that. There's the ledge.